Welcome to the tutorial on laws of exponents. On the left-hand side here we have the different laws. On the right-hand side we're going to make up examples that follow the laws. And my recommendation is honestly to not memorize the laws, but instead just write everything out the long way. For example, the first law says if you have two, it could be numbers, variables, whatever, that have the same base. Remember with exponents, there's a base. Let's say we have 5 to the power of 3. 3 is called the base, and 5 is the base, and 3 is the exponent or power. And so if you had to say 5 cubed over 5 to the first power, the rule for this first one says as long as the bases are the same, that you subtract the powers. So this would be x to the power of a minus b. Over here you would do 5 to the power of 3 minus 1 is 2. So the answer would be 5 to the power of 2, since the rule is to subtract the bases. And 5 squared can be simplified. It means 5 times 5, which is 25. And there's your final answer. So this could be an example of this particular law. And here's my recommendation for most of the problems in this list here. Instead of subtracting or adding or multiplying or doing whatever it is you're supposed to do, write the problem out the long way. It's more painful, but students are more accurate with this, and so that's what I recommend. So the meaning of 5 cubed, it means 5 times itself 3 times in a row. On the denominator, the meaning of 5 to the first power means 5, a single 5 by itself. And then you can see that 1 5 from the denominator will cancel out with 1 5 from the numerator. And essentially that's where the subtraction comes in, because when you're subtracting, you're saying how many of the bottom or top cancels out with the other thing. So left over are 2 5s being multiplied, and 2 5s multiplied is 25. So personally, I like the second explanation a lot better than just this subtract and I don't know why. So that's going to be my recommendation for pretty much all the problems that you do them without memorizing a particular rule, but you know how to do it by canceling. All right. Next up is x to the power, or xy to the power of a. Let's do this as an example first, and then maybe go backwards and figure out what the rule says. So remember, x and y can be anything. Numbers, variables, it doesn't matter. I'm going to use, say, I'll just xy. So let's say xy to the power of 4. Seems good. Now, a power of 4 means there's 4 of something being multiplied. And in this case, since there's parentheses around x and y, this means that we have 4 xy's being multiplied. So here's 1, x times y in parentheses. Here's another one, x times y in parentheses. And there's 4 of these guys total. So let me get these in here. There we go. So there's what the meaning of xy to the 4th is, 4 xy's. Now if you look and count how many x's are being multiplied, there's 1, 2, 3, there's 4 total. So the answer is going to be x to the power of 4. Count how many y's there are multiplied, there's 1, 2, 3, 4. And there's your final result by writing it out. There's no memorizing needed, just count what's there. So the rule is that you can distribute and basically multiply these powers right now are 1s. So you would multiply whatever power is inside by the outside power. So here it'd be x to the power of a and y to the power of a, because you distribute and multiply the power outside to the powers inside. So there's that one. Next problem, let me back up and erase. Right? X to the a times x to the b. Well, again, let's write this thing out and do an example. Let's say we have 5 to the power of 3, and then times 5 to the power of 2. So I'm replacing x with just some number. What matters if the bases are the same? It has to be x and x, not x and y or anything else. So if we write the meaning of this, 5 to the power of 3 means 5 times 5 times 5. The meaning of 5 squared is 5 times 5. So there's that guy. 5 squared is 2 5s in a row multiplied. And if we count, the total number of 5's being multiplied is there's 3 here and 2 here. And so we have a total of 5 to the power of 5, because there are 5 5's being multiplied. Whatever 5 to the 5th power is, that would be your result. So there's that one. Now the rule it looks like we should add these. 3 plus 2 is 5, so the shortcut for this one would be x to the power of a plus b. Remember, there's no need to memorize this stuff if you can do it the longer way and figure it out by making sense of it. So it depends on the style of student you are. I would personally recommend the long way because people are more accurate with that. That's what I've observed over the years. So if you want a better test score, honestly, write it out. Alright, x to the power of 0. Everyone I see puts 0 and it's wrong, so I'm going to go ahead and slash this out. It's not 0. We're going to use this law right here to figure out what this one should be. So think about this. Let's say you had x to the power of 4 over something that equaled an answer of x to the power of 0. Now, what would have to go down here so that you would subtract the exponents? Remember, this rule would be x to the power of a minus b. So in this case, what needs to go down here so that you subtract the powers and get a power of 0? Well, it'd be x to the power of 4, so that you end up doing 4 minus 4 is 0 for the power. And check it out. You've got x to the 4th power divided by itself. Anything divided by itself is 1. So it's surprising at first, but the honest answer is it's 1. So I'm going to go and erase this guy and put the correct answer, which is anything to the 0 power is 1. Until you reach calculus. In calculus, you can say that 0 to the power of 0 is lots of things. It depends on the context. So, but unless you have 0 to the 0, the answer is indeed 1 every single time. So there's that guy. Next up is negative powers. Negative powers, I think, are pretty awesome. In Algebra 2, you'll be using those quite a bit. So here's also an explanation of how to get there. Let's use this guy one more time to try to figure out a problem that would land at this. So let's say we have some problem over here, but we want the result to end up as x to the negative 1st power. So let's say we have x to some power here, x to some power here. Make up numbers that you would have to subtract to get negative 1. Let's say, I don't know, let's say 2 and 3, because 2 minus 3 would be negative 1. Now if we take this problem over here and simplify it, x squared means x times x. X cubed is x times x times x. And if we cancel, these guys would cancel out. Those guys would cancel out. Look what's left over. You have 1x in the denominator. So the answer is 1's left over in the numerator. When things cancel, remember it leaves behind 1's. But instead of writing 1 everywhere, which is, I find annoying, I mean, this is a technical case. 1's are left over all the place. So 1 times 1 is 1 on the top. On the bottom, you have 1 times 1 times x, which is x. And the end result is basically 2 x's on top canceled with 2 on the bottom, and 1 was left over. So x to the negative 1st power means the same thing as 1 over x. And the simplest way to think about this, I think, is that negative powers mean reciprocals. That's what happens at the end of a negative power. So x to the negative 1st power is 1 over x. And just, if you're going to memorize anything, memorize that a negative power means a reciprocal, and that's really the best route for you to go. Which means we don't have to do any work for the next problem. If we know that negative powers are reciprocals, check this out. X to the power of negative a is simply the reciprocal of x to the power of a, because the negative part of the problem means reciprocal. So x to the negative a, the negative right here, negative just means reciprocal, and so you'd have 1 over x to the a. And then for the final problem, x to the power of a times b, let's make up a problem to begin with. Let's say we have x squared and then to the power of 3. Fine. So let's write the meaning of this. If we have x squared to the 3rd power, that means we have 3 x squareds, because there's a 3rd power of these guys. So let's write that out. That means we have x squared times another x squared, and then times a 3rd x squared, because we have 3 x squareds. Now if you count these guys, there's 2 x's here, because this is really x times x, if you count it out. This one's also x times x, and the final parentheses, another x times x. So the total power of x we have is we have 1, 2, 3, 4, 5, 6 x's being multiplied, and so the final answer is x to the power of 6. And the shortcut seems like you multiply multiply powers to powers. 3 times 2 is 6. And so the rule is x to the power of a times b. Now, next tutorial, we're going to go ahead and apply these things to some problems. So if you want a chance to practice these rules, which I recommend, come on back.